we are starting chapter 3 today. So chapter 3 is all about parallel lines and angles formed by parallel lines and those kind of things. So we're going to get into the parallel lines tomorrow. Today we're just going to talk about different angles that are formed between lines and transversals and all those kind of things. So let's start here with some definitions. So some words that you guys know, but just kind of as a reminder. So first thing here, we have parallel lines. Now, in the past, anytime we've talked about parallel lines, we always kind of think about it in a two-dimensional space, okay? So like on a graph, okay, we can think of what parallel lines would look like. But we're going to start thinking about things in a three-dimensional space. Instead of like parallel lines on a flat piece of paper, think about parallel lines on a cube, okay? So parallel lines, not really a whole lot different than how you understand them before, but they're coplanar lines. So although we're talking about a three-dimensional space, if the lines are parallel, okay, they have to be on the same plane. What I mean by that is you couldn't have like parallel lines that go like that, but one's kind of pointing up and one's pointing down. Okay, they'd have to be on the same plane. Okay, and they do not intersect. So, like on this cube here, okay, we could say that that top left side and then that top right side, those would be parallel lines. They're coplanar because they're both on that top plane, okay? They're not going to intersect, okay? We could extend that to this idea of parallel planes. Now there's a lot of three sets of parallel planes on this cube, but one set of parallel planes could be the top and could be the bottom. That would be a set. Okay, so set of parallel planes. These are going to be one set of planes that do not intersect. Okay, so if you were to extend the top and the bottom, those planes would never cross. Okay, another option would be the two sides. Right, they're not going to intersect, or the front and the back. Okay, they're never going to cross. Okay, now the one word that is probably new is this idea of skew lines. Okay, skew lines in some ways, it's kind of the opposite of parallel lines. So parallel lines have to be coplanar. Skew lines are non-coplanar. They can't be on the same line. So that's kind of the first thing to think about, is that they cannot, if you were to have both of these lines and put them on the same piece of paper, you would not be able to put them on the same piece of paper, okay? The other thing is they don't intersect, but they can't be parallel. So what I'm doing with my fingers right here, that wouldn't work because those would be parallel in a way, okay? One would have to be maybe pointing this way, okay? So they're non-coplanar on different planes, okay? They're not going to intersect. If you look at what I have here, they're not going to intersect, okay? And they're not parallel, okay? So example on our cube here, if I talked about maybe this edge right here, a skew line, so a line that's not on the same plane, okay, so I couldn't use this side or this side that's on the same plane, okay? It's not going to intersect, okay, and it's not parallel, so I could do maybe that top edge right there. Or I could do that back top edge, or the bottom, or the side right there, okay? Although it may look like they're going to intersect just from like in a two-dimensional space, they wouldn't, right? Because this top one over here would go in front of it. Okay, so non-coplanar, they don't intersect, and they are not parallel. Okay, so we're going to be talking about those a little bit more later today. Okay, so the next big idea, this is going to be a huge idea through the whole chapter, okay, is this idea of what a transversal is. Okay, a transversal, it's a line that intersects two or more coplanar lines. Okay, so you have these two lines here, and you have a line that intersects both of them. The line that intersects these is called the transversal. Okay, transversal. Now, when you have two lines that are intersected by a transversal, if it's two lines and one transversal, you have 8 angles. Okay, now we can have a ton of different ways to classify all of these angles. That's what we're going to be talking about today. But there's kind of 2 big ways that you can classify the angles. Okay, these angles are either, first of all, interior or exterior angles, okay? Now, how you're going to know whether they're on the interior or the exterior is you're looking at the two lines, okay? So in this case, it's going to be line L and M, okay? The interior points are the lines that are inside lines L and M, right? Interior on the inside. So the interior angles here would be 4, 3, 5, and 6, okay? The exterior angles would be on the outsides of lines L and on the outside, the exterior of line M. So the exterior angles would be angles 1, 2, 7, and 8. So that's one way you can classify them, okay? The other way is talking about the transversal, okay? So that's dealing with the lines, okay? The two lines that you're talking about. You have the exterior angles, the interior angles. Now, if you focus on the transversal, what we're talking about is we're going to talk about pairs of angles. So if I were to pick any two angles, these two angles could either be on the same side of the transversal or they could be on opposite sides of the transversal, okay? If they're on the same side, we're going to call them same side angles. If they are on opposite sides, so one's on the right side, one's on the left side, you're going to call them alternate angles. Alternate, okay? Alternate kind of means the same thing as opposite, okay? So let's talk about a bunch of these different pairs of angles here, okay? So the first type of angle we're going to talk about are alternate interior angles. Alternate interior angles. Okay, the word alternate tells me that they are on opposite sides of the transversal. The alternate means they're on opposite sides of the transversal. So the first thing I do is find your transversal, okay? The transversal, okay, and your picture is always going to be oriented this way. We could flip it that way, but you find your two lines. The transversal is going to be the line that intersects them, okay? So since they're alternate, I know one of my angles is going to be on the left side of the transversal. One of my angles is going to be on the right side of the transversal. Now the other part says interior, okay? Now we're talking about the two lines. Since they are interior angles, these are two angles inside the two lines. Inside the two lines. So the space we're talking about, the interior space right here, okay, I'm going to pick my angles in there, okay? Now, I'm not going to use the congruent symbols, the arcs. I'm going to color them in because I don't want to imply that these angles are congruent. Okay, so I just want you guys to kind of note that, okay? But if I wanted to pick a pair of alternate interior angles, okay, the interior is going to be somewhere in this yellow space, okay? Alternate means if I pick my first angle over here on the left-hand side, it'll let me, okay? The other angle would need to be on the right-hand side, but still on the interior. So it'd be over here. It'll let it. Okay. Those would be alternate. See the alternate interior on the inside. Now there's another set of alternate interior angles here. You could take this top right angle and then the bottom left angle. Okay, those would also be alternate interior angles. Okay, we could do almost the same thing, but this time we can talk about same side interior. Since it says same side, these are going to be on the same side of the transversal. The same side of the transversal. Now they're still interior angles, so they are still going to be inside the lines. So we're still talking about this space here. Okay. But now we're talking about the two angles that are on the same side. So either the two angles that are both on the left or the two angles that are both on the right. I know it's kind of hard for me to draw up here. I'm trying to do arcs that are colored in, okay? They're not congruent. Don't assume that they're congruent. That's why I'm coloring them in. And I'm just kind of identifying which ones they would be, okay? Now let's come back to the corresponding angles. Let's jump down here to alternate exterior angles, okay? alternate, kind of like the first one, okay, if they're on alternate sides, it means that they're going to be on opposite sides of the transversal. Opposite sides of the transversal. But this time, since they are exterior angles, they're going to be outside the lines. This time, they're either going to be above the top line or below the bottom line. So the alternate part means I need to pick one angle on the left. The other angle is going to be on the right, but they do need to be on the outside of your lines. So that would be one set of alternate exterior angles. The other one would be the top right and then the bottom left down there. Alternate exterior angles. Okay, now let's come back to this idea of corresponding angles. So my best way I can come up with to kind of describe to you what corresponding angles are, we've got a lot of intersections here at Wichita. Okay, we're here almost pretty much at the corner of Central and Tyler. Okay, so if you wanted to talk about maybe the northeast corner of Central and Tyler, okay, we could talk about the businesses on the northeast side of Central and Tyler. I could go up to 13th and Tyler, and I could then talk about the northeast side of Central and Tyler. Okay, or I could go to 21st and Mays and talk about the northeast corner of 21st and Mays, or whatever intersection I said. Corresponding angles are going to be angles that are in the same location but different intersection. Same location but different intersections. So for example, okay, there are 4 sets of corresponding angles here. You're looking at the transversal, okay? So I could talk about the angle on the top right-hand side of the transversal at that intersection. That would be corresponding to the angle at the top right corner of that intersection. Or I could talk about the angles at the top left, or the angles at the bottom left, or the angles at the bottom right. Maybe I should do dots instead of the colored in arcs from here on. Okay, but corresponding angles. Same location, different intersection. Okay, corresponding angles. Okay, questions on any of this? Okay, I think we should have set up our table of contents yesterday. Hopefully it should be on page 31, which means this is going to be on page 33. Going to be section 3.1, and we are talking about lines and angles. Lines and angles. All right, so let's talk about our first diagram. We'll draw this together. Okay, what I want you to do is draw like a long rectangle. Okay, long rectangle. We're going to draw a 3-dimensional rectangular prism. Okay, now on your long rectangle at the top left, right, and then bottom right, go ahead and draw a line going in the same direction and the same distance from each one of those corners. And then you can connect the back and the top. Okay, and there's your rectangular prism. Now what I want to do is I want to show the edges that you can't see, right? So this back edge right here, since I can't see it, let's show it as a dotted line. And then that vertical edge going back. And then this one going across here. There we go. There's your art lesson for today. How to draw a rectangular prism. Okay, and then I want to label the vertices. Okay? So we'll start with this front left corner. Is going to be A. We're just going to work on the bottom clockwise here. So B will be the back one, C will be the back right, and D will be the front right. And then we'll start at the top, and we'll do E, F, G, and then H will be right there. Okay, so we'll use this figure for the first 4 examples. Okay, so let's start by talking about parallel planes. diagram, and let's see if we can name parallel planes. Now, as a reminder, to name a plane, you have to have at least 3 points on the plane. So I want you guys to think about this for a second. Maybe you can get something written down. See if you could name a pair of parallel planes. We're going to need at least 3 points for each one of the planes. And there's actually a ton of different answers here because there's a ton of different ways you can name each one of the planes, okay? All right, who thinks they have a pair of parallel planes for me? Go ahead, Elijah. CDH. Okay, that would be this right side. And then what one? ABF. Yeah, very good. Everybody erase those? And ABF. Now, keep in mind that you could have named that right side DCG or HD. There's a whole bunch of different ways, but the right side and the left side. Okay? Anybody have another set? Which would be the top, EFG, and ABC. That would be the bottom. That would also be a set of parallel planes. And once again, different ways to name EFG and ABC, but yes, top and bottom. And what's the last set of parallel planes, Grant? ADH, which is that front. And BFG, which would be the back. Excellent. Very good. Okay. Parallel planes. Okay. Number 2. Let's name all lines parallel. All lines parallel to line EF. Now remember, with the notation for line EF, use a capital E, a capital F, and then you draw the line that has 2 arrows on the end, okay, to indicate a line. So line EF, maybe we find out right here. I want a line parallel. So remember, if it's parallel, it has to be coplanar, okay? Will not intersect. What is a line? And there's a couple options here. Which one? HG would work. So we're going to say HG. Make sure we say line HG. So put that over top. That would be one. What's another option? Sam? AB would be parallel. AB. What else, Grant? And DC would also be parallel. And I think that was it for those parallel lines. Very good. Very good. Okay, let's talk about kind of what I think about as the opposite of parallel lines. Let's name 2 lines skew. 2 lines skew to line AE. 2 lines skew to AE. Now AE is right here. Now remember, if they are skew to AE, they cannot be on the same plane. So since AE kind of goes like straight up and down, you cannot pick another line that goes straight up and down because that would be coplanar. It cannot be coplanar. Who thinks they can find a line skew to AE? What do you think? HG would work. Absolutely. HG would work. Yeah. Okay. That's another one. Brianna? DC would work. Excellent. DC would work. It only asks for 2, but anybody got one we didn't list already? Go ahead, Elijah. BC would work. FG would work, yeah. Yeah, I think that was going to be all of them. Notice that AB wouldn't work. Why wouldn't AB work? It intersects it. Yep. It's not coplanar and it's not parallel, but it intersects it. So AB would not work. Okay? Do we understand skew? Okay. And then last one here for this, our lovely little drawing here. Let's find a plane parallel to line BC. A plane parallel to line BC. Okay, now, keep in mind, do is you have to understand what they're asking for. They're asking for a plane, like a sheet of paper, right? So you need to give me 3 points, okay? A plane that is parallel to BC, which is that back bottom edge there. A plane parallel to BC. What do you think, Elijah? EFG, the top, right? That would be parallel. Plane EFG would work. I think there's, and once again, you can name it different ways. You could say HGF, but it's the top, okay? What other plane is parallel to BC, Roberto? EAD. Excellent. The front. Excellent. Very good. EAD. Very good. Okay, how do we feel about parallel planes, lines, skew lines? Okay, got another picture here. This one is just lines, okay? But there's kind of a lot of them, okay? So this one. All right, first thing, we're going to label as we go. I want you to draw 2 kind of diagonal-ish lines here, okay? And we'll name them, the left one, line A, the right one, line B. And then we're going to draw 2 horizontal lines, just going across here. It kind of looks like a little zigzaggy tic-tac-toe board. And we'll call these lines C and D. And then the last line is going to cut through at these corners. Okay, and this will be line E. Okay, so there's our diagram there. We have 5 lines. Okay, but I'm gonna label some of the angles. I'm not gonna label all of the angles. So let's start first at this top left intersection. Okay, and we're gonna start down here 1, 2, and 3. Angles 1, 2, and 3 at that first intersection. Okay, over here on the right, we'll do angles 4 and 5. And then this bottom left intersection, we'll do angles 6, 7, and 8. So yes, there are other angles in this diagram, but these are the only ones we're going to worry about. So here's what we're going to do. I'm going to give you an angle relationship. We want to find all of the possibilities. Okay, so these are going to be the alternate interior, same side interior, those ones, okay? So we'll find all the possibilities, okay, of the numbered angles. Then what we're going to do is we're going to decide what 2 lines in transversal creates those angle pairs, okay? So number 5, let's start with finding alternate interior angles. Alternate interior angles. Okay, now first thing, guys, it might be easier to think about the interior part because there's a bunch of alternate interior angles here, but they're not all labeled, okay? So keep in mind that the interior, okay, and I'm going to kind of scribble in here a little bit, would either have to be a pair of these angles, right, because they're on the inside of those lines, or, guys, it could be these ones, right? Okay, so we need to find sets of points that are either inside either one of those, but remember, they have to be an alternate opposite sides of the transversal. Where this gets tricky, so I've kind of got a bunch of different transversals, right? Because if I'm talking about lines C and D, there's actually 3 transversals there, right? There's transversal A, B, and E. Okay? Who thinks, while you take a second to look at that, alternate interior? What do you think, Grant? Angle 1 and angle 6. Look, they're on the interior. See that? Okay? And they're on alternate sides of that transversal. So we'll say angle 1 and angle 6. I think it's easier to start by naming the transversal. I don't know why. What transversal are angle 1 and angle 6 on opposite sides of? Right there. Line A. Okay? So, line A. Now, what 2 lines are the 2 lines that they are interior of? 1 and 6. What are the 2 lines that they are interior of? C and D. Very good. Lines C and D. Okay. And there are other alternate interior angles here. They're just not labeled, right? Like angle 5, and then that angle is not labeled. Okay, so those are actually the only sets of angles I can identify because those are the only ones that are labeled. Okay, now this one might have a couple options. Let's look for same side interior angles. So on the same side, still interior. So we're still looking right in between either sets of those two lines. Okay? But on the same side of the transversal. So maybe, so I don't know if you want to maybe pick out a transversal and see if you can find some that are on the same side. Elijah, what do you think? Angle 4 and angle 5. Okay, they're both on the right-hand side of that transversal. Yeah, and they're inside those two lines right there. So angle 4 and angle 5, they are on the same side of what transversal? They're on the same side of what transversal? B. Very good. And they are on the interior of what two lines? C and D. Very good. C and D. Okay, now, there is another set of same side interior. What'd you say? 6 and 2. Yeah. Okay, 6 and 2. Okay, now you have to be kind of careful here, okay? So angle 6 and angle 2, okay, they're on the same side of the transversal A, right? Okay. What two lines? I had C and D, but I don't think that's right. These are so hard. I had C and D, but I don't think that's right. I think it's D. I feel like it's D and E. Yeah. I feel like it's D, this line and this line. It's D and E. Okay, see this line right here? D and E. That's the one it is. I had the wrong answer in my notes, and I think I told the wrong answer. It's lines D and E. Now, I did, in your homework, I was going to have you guys do corresponding angles. Oh, but it's a nightmare coming up with all the corresponding angles here. It's confusing. So I'm not going to worry about the corresponding angles. We'll get to those in our last example. Okay, the last ones, let's do alternate exterior angles. Alternate exterior angles. Now this time we're talking about angles on the outside. Okay, so any of these angles, okay, that you can find a pair of, okay, on the outside. Anybody think they can find a pair of alternate exterior? Go ahead, Elijah. Angle 8 and angle 3. Now, angle 3, I'm not sure that one would work because it's on the inside, I think. My goodness. I think, okay, let's do that. Angle 8 and angle, we have 3 examples, right? Okay, so angle 8 and angle 3, okay, which would be on the alternate sides of transversal A, and then what lines are creating them? That would be D and E. Yeah, lines D and E. Okay, I think the other ones are maybe a little easier to see. Let me see another set. What do you think? 1 and 7. Now, that would be on line A, right? Okay. 7 is an exterior angle, but 1 would be an interior angle. Yeah, let's look at 1 though. Okay. 1. Now 1 and 8 are on the same side, right? What about 1 and 5? Does that work? Going away? Yeah. Okay. 1 and 5. So angles 1 and angles 5 are, yeah, they are outside of lines A and B. They are outside lines A and B, and what is my transversal there? E. Transversal E. Okay, the other set I came up with was 8 and 5. 8 and 5. So on the outside of A and B, see that? Okay, so angle 8 and angle 5, they are outside lines A and B, and they are on opposite sides of transversal D. Okay, you have 3 examples in your homework that are very, very similar to this, okay? It gets pretty complicated, and there's kind of a lot to sort through whenever there's multiple transversals and multiple sides, okay? All right, last one here. Last little picture here, okay? Let's draw a nice little diagonal line here, okay? And then we'll draw a horizontal line. And then draw a line that kind of slopes down, and then we'll draw a line that kind of slopes up here. That's be exactly like that, but pretty close. Okay, what I'm going to do is I'm going to number them in different colors, because what we're going to do is we're going to look at the angles that are labeled in the same color and classify them. So if you don't have different colors, maybe what you could do is the 2 that I do in purple, maybe put circles around them, and the 2 that I do in blue, put triangles around them. Okay, you can do that. So the first ones, we'll do angle 1 and angle 6, those 2, okay? We'll just leave those in black. We're not going to classify those, okay? In green, I'm going to label angle 2, and then this in the middle here, this top left side is going to be angle 3. And then I'm going to do in orange, angle 4 right there, and then that bottom right is going to be angle 8. And then my last 2 angles will be 5 and 7. So once again, if you don't have different colors, that's fine. Maybe just like put circles around 2 and 3, put triangles around 4 and 8, put squares around 5 and 7. Just some ways to show that these are the angles that are paired up. Okay? Okay, so we're not going to classify 1 and 6. There is no relationship there, so we won't worry about those. Well, let's start with angle 2 and angle 3. Angle 2 and angle 3. So there's kind of 2 things you have to decide typically, okay? Are they interior, exterior, and are they same side or alternate? So if I look at 2 and 3, are they interior or exterior? 2 and 3. Interior, they're on the inside of those 2 lines, right? So they're interior angles. And then if I look at the transversal, are they same side or alternate? Alternate. So they are alternate interior angles. Okay, let's do angle 4 and angle 8. Now angle 4 and angle 8, okay, if I'm looking at these 2 here, 4, if you're looking at this relationship, is an exterior angle, and 8's an interior angle, so they don't work out that way. And they're on the same side. So I can't classify them as alternate interior or alternate exterior or same side interior or same side exterior. What are they? They're corresponding angles. See how they're both in the top right corner of that intersection? These are going to be corresponding angles. And then last ones, angle 5 and angle 7. Okay, angle 5 and angle 7, are they interior or exterior? Interior, same side or alternate? They're both on the left side. So these are going to be same side interior angles.